and welcome back to AI Business TV. I'm delighted to be joined by Mark Heaps, Head of Brand and Creative at Groq. Thank you for joining us.
Thanks for having me. Happy to be here.
So tell us a little bit about Groq and what you're doing at the show today.
So Groq is a startup that is building new technology solutions for people that are processing AI, which is why we're at this event. Obviously, there's a lot of great companies here trying to show the ways that they're advancing AI, and we happen to be one of them.
Great. And so can you tell us a little bit that we might not know about Groq, about the company, the technologies, and your leadership?
Yeah, absolutely. I'll probably take that question backwards because that's the easier detail to share. So our founder and CEO, Jonathan Ross, he was the inventor of the Google TPU. And so when Google was needing to figure out a solution for the future of compute for their own services and products, he was instrumental in developing that chip. A number of years later, he ended up forming Groq. And so Groq started by inventing a new type of architecture that's completely deterministic. And it started in a very unique way, actually. Instead of going into the hardware first and basing it on what we know as legacy architectures, he started with the developer focus in mind, he himself being a software developer traditionally, which is a bit strange that he invented a hardware chip before, but he's a software guy. And so they started by developing the compiler for Groq first. And so they started with the compiler, figured out what they wanted that to be, and then developed the architecture around that as a solution. So what that means today is we actually have a compiler up and running that allows developers the easiest path to getting their AI and ML models up and running on a processor compared to traditional legacy solutions that are out there.
So what is keeping your customers up at night? What do you think are the main challenges people are facing?
Yeah, so we hear lots of different things because this is sort of the Wild West right now, right? AI is an emerging space. I mean, we say that even though it's been happening for obviously the last decade plus, but what we hear from our customers and why they work with Groq is really in two key arenas. First, the developer experience. So because we have everything based and built and controlled by our compiler, developers today that are working with, say, like CUDA libraries from NVIDIA, or they're completely developing kernels from scratch, it's taking large teams months and months at a time to get a model up and running and actually into production. Since early this year, we've actually got over 500 models running on our compiler, and we're just seeing that exponentially blow up because of what we've done with the compiler. So if a customer has a concern about the time to production or the complexity that a developer has to go through to get their system up and running, they're coming and talking to us. Outside of that, the other side customers are really excited about is just inference speeds. We know that there's a particular drop-off with the GPU systems that are out there today and even CPU systems. So if we can get the time to production very quick for the company and at the same time give them record-breaking speeds and performance, then they definitely are excited to be talking to us.
And what is Groq doing in terms of addressing usability issues?
Yeah, so we have a proprietary tool that we built that's called Groq Flow. One of the really interesting things when you build a proprietary architecture, the assumption is, kind of even going back to the days of Cray, is that people go, oh, you have a new form of hardware, you must have some new language we have to learn, like an OS or something like that. We don't, actually. So today, any developer that works with PyTorch or Onyx or TensorFlow can actually use our tool called Groq Flow, and it's a single line of code, an instruction that literally says Groq it, and they can actually put their model through that, and it will tell them exactly what their benchmark performance will be, if they're missing anything from their model, to actually have that mapped to our chip. And you can even say, I want to run this on one chip, or I want to run this on 4,000, and it will help in the mapping to our hardware. And so with us, we're simplifying that experience for the developers and for the customers because they don't have all these multi-cores that they have to manage with instruction sets and controllers and more. So there's that side of the experience. For the people that are in the data center that really have to make sure that equipment doesn't fail, because of our chip-to-chip technology, we actually don't use any routers and switches in our systems. So we're eliminating multiple fail stages, other areas that draw power, and limiting or removing some of those components that would affect data flow and data path. And so because of that, we see less corruption in the data as well. So these are some of the things that make it a little bit easier for our customers to work with our system.
And what do you guys see as the value of the convergence of HPC and ML?
So this is one of those areas that people have been talking about for a really long time. You know, the complexity of traditional HPC systems is you're working with all of the data, right? But to move into the world of ML and this convergence, we hear from a lot of people saying, well, but we don't want to sacrifice accuracy, right? We understand that you can process the data and do some predictions. You can have some probabilistic methods to tell us what the output might be if we processed 100% of the data. But we know that traditional HPC workloads, those folks are still really, really nervous about moving into AI and ML. Today, with ultra low latency and the slicing, the size of the batches that we can process, we can actually get a much higher degree of accuracy than what people saw before. So now you have a situation where you can do a greatly reduced data set or segment of your data and get the equivalent quality that you would have gotten with traditional HPC. So this means faster time to insights, faster actionable decision making, and more. So that's actually what we're going to be speaking about here at the event.
Okay, so that's on the headliner stage tomorrow, isn't it?
That is the headliner stage tomorrow,
okay.
Yeah. We have, just as one example of that, we have a computational fluid dynamics demo. And there's a visualization component of that where you see traditional HPC, which gives us that benchmark of quality to see how accurate is the detail when it's rendered in this model. And we actually break down what are the differences when you're doing a pure ML, which is not getting the level of accuracy that we know from HPC. But then we show a hybridized version where you're getting that converged methodology, and we're doing it with much less intensive levels of compute, much less of the data egress that you have to consider, and still maintaining, literally in the visualization, you can see the accuracy.
Okay, so we're coming up to the end of the year. What do you think is next for 2023 for Groq and also AI in general?
Yeah, one of the things that I think everybody's really excited about right now, especially if you're watching in like news media and even getting to the general public, right? Everyone's talking about generative AI. You know, we hear about chat technology, like the new Chat GPT model that everyone's talking about. We know that everyone's excited about these image generation models like DALL-E, Stable Diffusion, Midjourney. And that's all the way up to large corporations like Adobe. You know, we have meetings with a lot of these Fortune 50s and Fortune 100s, and they're all trying to figure out how are we going to take advantage of this. For us, we're considering this the next stage of AI's evolution, and we're calling it the creative age of AI. You know, before now, traditional systems like legacy GPUs were really going from traditional compute as a bridge towards AI. But the size that the models are becoming, you know, we didn't think we would get to this scale for probably another year or two at least. And suddenly the community is so passionate about this creative movement in AI that you just see tens of thousands of developers all sharing ideas so that they can expand on what that technology can do. So for us, we really add a lot of value when you're talking about processing at scale. With traditional GPUs, again, after you hit about 64 chips, you start seeing kind of an erosion of the value that you get out of the GPU. It sort of flattens out, right? For us, we can get into thousands and thousands of chips and have this linear scalability. And so for us, we feel like we're really in an opportune time to see these creative age and the demand at scale rapidly growing, and we're right there ready to meet them.
Brilliant. Well, enjoy the rest of the day. Enjoy the rest of your time at the AI Summit, New York. Thank you.
Absolutely. Thank you very much. Thanks for having me.